All right, so absolute value graphing, and we kind of did this yesterday, but today we're going to focus in on graphing absolute value. We've got graph paper today, so our graphs need to be more accurate than the kind of the quick sketches we were doing yesterday. Looking at number 1, I see 2 changes that have been done to the parent function. So, Kennedy, you get to go first. Tell me one of the changes. All right, left 2. I like that because of that plus 2. So, Caroline, how about that plus 1 at the end? What's that do? Good. You said move the origin up 1. I'm okay with that, but it moves everything up 1. But you're right, it's going to move the vertex up 1, and then we can kind of go from there. So, left 2, up 1. It's absolute value. Now, that's kind of easy today because everything today is absolute value. But it is a little bit humorous, or frustrating humorous, when students get the transformations right and then graph a parabola instead of an absolute value. Like, oh, come on. And they realize it's a dumb mistake as soon as they see it. So just be careful. Obviously today, not a big deal. Everything's absolute value. Left 2, up 1. And from there, we know it's an absolute V for value. So we can sketch in our over 1, up 1. This one did not have a stretch on it, so it's that standard slope of 1 on either side. So there's our picture. Left 2, up 1. Number 2's got 3 things wrong with it. So, not wrong, I shouldn't phrase it like that. There's nothing wrong with it. 3 changes from the parent function. We'll phrase it that way. So, Liam, you get to go first. Tell me one of the changes to the parent function on number 2. I'm going to go right 1. I like that. Rena, tell me another change. It's going to be flipped. Horizontal or vertical? Vertical, good. Jack, that only leaves one thing for you to tell me what's happening or what's left.
It goes up 3.
Up 3. Okay, so right 1, up 3, and then be careful, it's flipped, so instead of the normal one, it's upside down. So down 1, over 1. Still a slope of 1, just an upside down slope. And I should be putting slope in like quotes every time I say it because it's not officially a slope, but that's the best way to describe it. This seems silly, it seems like extra, but take 10 seconds, reread what you wrote and make sure it's what you drew. Right 1, up 3, and flipped. Because the mistakes happen, like almost everyone gets the transformations right, and then somehow they don't always make it from the words to the graph. And so when students get their test back, and they're like, how did I miss that? I said it was flipped, and then I didn't flip it. So take the 10 seconds to double check that what you graphed is what you wrote. Nicole?
Could we just graph it and not have to write it down?
So I'm okay with that. I think it would be safer if you wrote it down, but you don't have to. Okay? So yeah, do you have to write them down? No. The review and the test has some questions that are just basically write them down without graphing, and then some of it's graphing. So yeah, you don't have to write it down, but encouraged. Okay, how are we feeling on these so far? Yes, no? Maybe so. Then let's skip 3 and 4. And then we need to make some changes to the back to make sure we hit the things that are on the homework. Right? Nothing more frustrating when you get an assignment that is not covered in the notes. So to fix that, we'll skip number 5 as well. On number 6, put a 2 in front of the absolute value. Yeah, oh. But we'll let Carson and Megan explain what the changes are there. So Megan, you're first. You get to pick. I've made them both 2s, which is probably not the best, but tell me one of the changes to the parent function.
It'll go up 2.
Which 2 makes it go up 2?
The last one.
Good, the last one. So we'll go up 2. So Carson, what about that 2 in front? What's that going to do?
So stretch by 2.
Stretch by 2. Which way are we stretching? This way or this way?
Oh.
Okay, the vertical stretch. Good. Okay, so up 2 to start with, and then a vertical stretch after that. So our slope, quote, slope, up 2 over 1. Stretch it out. Number 7, just flat out change number 7. We need to do some adjustments here to match the worksheet. So change that to y equals absolute value 2x plus 2 plus 1. So what is different about that one?
2's inside that.
The 2's inside the absolute value. So you can see maybe already that is going to be a stretch, but it messes up finding the left and right transformation, because it just needs to be x plus something or x minus something, not the 2 on there. So any idea what we could do to just get x plus something or x minus something? I don't really want to divide by 2, but I could pull out the 2. Very similar things, but let's factor out the 2. Now I've got x by itself, so now I can get the left-right thing correct. So it didn't really change the stretch thing. We're still stretching by 2, but we got to look carefully now. You might have thought it was a left 2 transformation, but when you factor out that 2, go ahead. It's what's the left-right transformation, Ryan? What's plus 1 do to the graph? Or x plus 1. It's left 1. There's still 2 other things going on there. So, Nick, tell me something else that's been changed about that from the parent function.
It goes up 1.
Up 1. And, Dantre, what else has happened? So we got the left 1 and the up 1 accounted for, but there's still a 2 out front. What's that do? Dantre, what's that 2 out front do? Stretch it. Vertical stretch. And Nicole, maybe you're still not going to write these down, but the argument for writing them down would be when you get a more complicated problem and you got more things going on, it might be wise to sort of force yourself to slow down and write them out. But maybe you're still going to be like, no, I got it. Up to you. Okay, left 1, up 1. Left 1, up 1. Vertical stretch. So it's still pointing up. I need to stretch it out. It sort of has the slope of 2, up 2 over 1. And then again, try it where you just quickly check and make sure. Vertical stretch, left 1, up 1. Yeah, so I feel good about that graph. All right, why don't you try number 8? Let's change number 8, though. Let's put another, where you have to do similar to what you did on number 7. So change number 8 to y equals negative absolute value 3x minus 9 plus 4. And I feel like that's just about as complicated as we could make one, because it's got all the changes and you got to factor out the thing. So you try that one. I'm going to pause the. Okay, so factor out a 3, but only a 3. Like that negative's already out there, so leave the negative alone. You'll never factor a negative out of an absolute value. That doesn't work. The absolute value makes things positive, so that really, don't do that. but just a 3, you can take a 3 out. That leaves x minus 3 on the inside, and then we're ready to start thinking about what's happened here. So up 4, right 3, stretched, and flipped. So like all the things that could go wrong have gone wrong here.
That's the hardest it's going to get.
Right 3, up 4. Almost. Almost. Going to make one more little change to things. Right 3, up 4. Flipped, stretched by 3, so my slope is 3, but down 3 over 1. Down 3 over 1. There we go. Questions on that one? Ryan, what did you just say? Not the second. What did you say before you made the comment about your opinion on inequalities? Because that's the last thing we need to do that we haven't done yet. Yeah, so let's change number 9. Let's make it less than or equal to. Because there's those in the homework, but they're not in the notes. You're like, oh, we need to fix that. We haven't seen one of those in a while. So you remember how to handle graphs with less than or with less than and greater than stuff? Did y'all graph those with lines?
Oh, yeah. It's just,
Okay.
It's been a long time.
It's just been a while.
I didn't do it.
Okay, so how to handle the less than or greater than stuff is handle it at the end. So just graph it. Our first goal is to just graph y equals 2 times x minus 2. And then we'll worry about the less than and greater than stuff.
I'll take that.
So we'll start with the easy part. Oh, never say it's easy and then call on people because that's dangerous. Cole, I got 2 changes there. Tell me one of them. Right 2. Luciana, tell me the other change. Good. Stretch by 2. So right 2, and then we'll stretch by 2. So a slope of 2. There's this thing about a solid line or a dashed line.
Oh, this one's solid.
Why is this one solid?
Because it's equal to.
Because it's equal to. If it's equal to, you want a solid line. Probably should have done one that wasn't equal to. That way we'd have to see the dashed line. So solid line for equal to. So if you remember that, great. If you need to. So if the equal to sign is on there, then it's a solid line. If it's not equal to, then it's a dashed line. And then how do I know where to shade? If it's less than, that means I want everything less than. Don't think outside, inside. Think up and down. Y is an up and down thing. So less than is, I want all the y values that are less than the v, so that's under the v. So less than means shade below. So less than or equal to is shade below. Greater than would mean shade above. So I'm not going to do that with the pen. Okay. So absolute value parent functions combined with transformations, left, right, up, down, stretch, flip, combined with your previous knowledge of less than, greater than stuff. So solid versus dashed, shade above versus shade below. And then for that kind of question, you got to put it all together. A lot of things. Are you feeling okay on this stuff? Okay. Then your assignment is that next page. It's only the front. It's 9 graphs and then 3 equations. So your assignment is that the next page, absolute value functions. 9 graphs, and 3 where you given the equation or given the graph, write the equation. Just be careful because some you got to factor out. Some have less than, some have greater than or equal to. So there's a lot of things going on there.
Is it due Monday?
Less than is shade below. The packet, the whole packet will be due on Wednesday. But in your mind, you should think it's due Monday. That way, you'll have it done by Monday. That way, you can ask questions if there's anything to. So let's see. Oh, that still leaves you 30 minutes. So you could probably finish that, and then still have time to study for chemistry, or world history, or whatever. It's a chemical symbol for potassium. Okay, look at you guys. Sodium?
And Jackson actually studied these. He did kind of.
I did that. I did study for a project in 5th grade. It's the only one I know.
Well, in 6th grade, I did.
Copper?
C.
Oh, yeah. Carbon? I think I'm almost out of them. Out of the ones I know.
I think that will be like type questions. I don't know.
Which is a problem with C.
Helium.
H. No, He.
Ah, gotcha.
Hydrogen.
Oh, I'm still recording. Thanks. Hey, video people, you're still watching. Why are you doing that? You got some chemistry knowledge going there. Good job.